Today, we're looking at a subtle but significant development under the radar in software infrastructure that quietly affects millions of devices worldwide. You might not notice it on the surface, but this shift could influence performance, developer experience, and the pace of innovation in the tools that power modern programming. Claude Code, an AI-powered coding assistant, recently transitioned to using Bun, a JavaScript runtime environment rewritten in Rust. For context, Bun is similar in purpose to Node.js or Deno, providing the runtime that executes JavaScript outside the browser. The big change here is that Bun was originally written mostly in C++, but now a Rust port of Bun is in production use with Claude Code version 2.1, 181, and beyond. Why does this matter? Rust is a programming language known for safety and speed. By rewriting Bun in Rust, the runtime becomes more reliable and efficient. Jared Sumner, the developer behind Bun's Rust port, notes a startup speed improvement of about 10% on Linux systems. While it may sound incremental, these gains add up when scaled across millions of devices running Claude Code. And perhaps more importantly, this rewrite opens doors for more maintainable and secure codebases. Digging into the technical evidence, users have confirmed through direct inspection of the Claude Code binary that it indeed bundles Bun version 1.4.0 in its Rust incarnation. This version number is ahead of the latest official release on GitHub, indicating Claude Code is running a canary or preview build. That means they're embracing cutting-edge tech, albeit in a stable and controlled way. In the short term, this move means that developers relying on Claude Code can expect a smoother, faster experience with less latency in their coding workflows. For the companies building on Bun, it validates the Rust rewrite as production-ready and capable of handling heavy usage at scale. It also signals that Rust's influence in backend and runtime environments continues to grow, challenging traditional languages like C++. On a daily life level, while end users might not see direct changes, the indirectly improved speed and stability can enhance everything from the responsiveness of AI-assisted coding to the security posture of the tools they use. Looking further ahead, this transition to Rust-based runtimes could accelerate a broader industry trend of rewriting critical infrastructure components in Rust. The language's growing ecosystem and emphasis on memory safety reduce vulnerabilities that have long plagued software written in older languages. Over the next decade, we might see more development tools, servers, and runtimes adopting Rust to strike a better balance between performance and reliability. For jobs and the workforce, this evolution means software engineers will increasingly need to be familiar with Rust alongside JavaScript and other languages. It may also shift hiring priorities toward developers who can navigate Rust's unique paradigms. Companies that adapt early will gain a competitive edge in building faster, safer tools. Privacy and security are subtle but important beneficiaries here. Rust's design helps prevent common bugs that can lead to exploits, making the software ecosystem more robust. While this is a back-end improvement, it contributes to overall trustworthiness in the software we depend on daily. To sum up, the adoption of Bun rewritten in Rust by Claude Code is a quietly impactful milestone. It's not flashy, but represents steady progress in software tooling infrastructure. As the saying goes among developers, boring is good. Stability, speed, and security improvements may not grab headlines, but form the foundation for the next generation of software innovation. In the coming years, keep an eye on Rust's expanding role in runtimes and developer tools. These shifts shape the future of how software is built: faster, safer, and more reliable.